So everything that we're about to talk about here should be familiar to you, either because we've talked about it in this class or because you had talked about it maybe in middle school. This should all be review and things familiar to you. But our entire next chapter that we're doing here is going to be about triangles and right triangles in particular, and finding different side lengths of right triangles. And so I want to make sure that we're all on the same page and are all building on the same foundation here going into this next chapter. So first off, angles in a triangle. The angles in a triangle all add to 180 degrees. That's thing number one that you should know. And that's something that we even talked about in the last chapter. It came up in a couple of problems. So for example, I want you to get some answers for me in the chat if you can for a couple of these examples. If, let's say, we know that this angle here is 38 degrees, as an example here, I want to know what the measure of angle C is supposed to be. So go ahead and take about 30 seconds to figure that out. All right, if these all have to add to 180, this is 90, and this angle is 38, so that leaves 52 degrees for angle C. Right, the total of these angles is 128, and we want to get to 180. That means we have 52 to go with that subtraction. As a matter of fact, whenever we have a right triangle like this, if we got some right angles, then we can just say, well, this is 90, so there's 90 left for these two angles, and just subtract this 38 from 90, and we'll get the same thing. In other words, angle A and angle C here are what we call complementary. Complementary, they add to 90. Because we have 90 here, that leaves 90 for these other two angles put together. So that's a shortcut you'll kind of see me use sometimes. All right, a couple other terms. Hypotenuse. We talked about this. There was a whole theorem for congruent triangles called hypotenuse leg. So we've definitely talked about this. Hypotenuse is the longest side in a right triangle across from the right angle. And one of the keys in this is right triangle. There's only a hypotenuse when we're talking about a right triangle. But it is this longest side, so I'm standing at the right angle, and I look across from it, and I see side A to C. This side right here would be my hypotenuse. So the hypotenuse here is A to C, segment A to C, which is 10. Again, these are all going to be terms that are going to be really important in these next couple of chapters. Now, the other two sides that build the right angle are called legs. So if you trace out the right angle, the two sides that you create will be the legs. So in other words, this side here, tracing out the right angle. So these two sides trace out the right angle. So they are both legs. Here's a leg, and here's a leg. And sometimes we even distinguish between them by saying that this is the longer leg and this is the shorter leg. But both of these are legs that are used to build the right angle. So that is segment A to B. In this triangle, it's segment A to B and segment A to C. All right. Perimeter. If you know what it is and want to work ahead of me, then the question I'm going to ask here is find the perimeter of this triangle. So if you remember what perimeter is, go ahead and do that while I write down the definition of perimeter. And if you didn't know, now you should be able to figure out what the perimeter of this shape is. Adding up all the sides, distance around a shape. So a common kind of application or example of this is, I want to build a fence around or some kind of border around my yard, or I want to have a certain amount of space in my room. And so I'm going to measure all the side lengths, basically all of my borders, and I'm going to add them together. Right? So this is adding up all the sides. That's what a perimeter is. So in this case, perimeter would be, I just add up the sides. My side lengths are 6, 8, 10. And then the last thing I have to talk about here is area. And area, we're going to do a whole week on area, probably the week before spring break here. But for a triangle, the area formula, you'll see it happen a couple times in this chapter, is 1/2 the base times the height. 1/2 the base times the height. And the thing to remember when we do area formulas is that the base and the height have to be perpendicular to each other, which, good news, in this triangle, we've already got the base and the height perpendicular because we are making this right angle right here. So we can just say that the base is 6 and the height is 8. We can just use my two legs to make the area. So to recap everything that we've talked about here, in a triangle, the angles have to all add up to 180 if I add the three angles together. When I make a right triangle, I can put my sides into two different categories: the hypotenuse, that longest side across from the right angle, and then my two legs that are used to build the right angle. And then I wanted to make sure we had our difference between perimeter and area. Perimeter is our distance around the shape. The area is, if I were to shade inside the shape, how much area would that be? 1/2 base times height. Find perimeter, we just add up all the side lengths. And where this is all headed, what we're going to spend this chapter kind of focusing on is Pythagorean theorem, especially over the course of the next week or so. So that's what we're going to start on tomorrow.